Hello, good afternoon. Teacher Seppi again. Okay, so I'm just going to discuss. Oh, wait, I'll just share this very well. Okay, wait for a while. I'm going to discuss about the special products and factoring. Uh, I am just like sharing this for a while. Okay, so there you go. We have like common, what's this? Common mistakes of those people usually have difficulty in dealing with like special products and factoring. When I say special products and factoring, you don't really need like to spend time in solving word problems regarding this. It is because it is specially designed. Uh, anyway, the first rule we have here. Um, we have here like x squared minus y squared. If you'll see this kind of what's this question, this is just like the product of the sum and difference of the two variables involved. Okay, so just copy x minus y and then times x plus y. That's it. Okay, like for example, x squared minus 9. So we have here 9 is 3 squared, right? So we have there like x squared minus 3 squared. So this is already in this case the same with that. So we have there x plus y, no, sorry, x minus plus 3 and x minus 3. That's it. There is no such thing as like problem with which comes first, because anyway they're just like multiplication, so we can have like x minus 3 times x plus 3 or the other way around. Next one, there are like actually variants with this, like shall I say x squared minus 1. How are you going to do this? Remember that 1 can be expressed in cube, in squared, or in the raised to 4 and stuff like that. So we have there x squared minus 1 squared, right? We can have like this because 1 squared, 1 times 1 is just the same as 1, right? Okay, don't be confused. Some of the questions are like 2 squared and 2 parentheses squared. What's the difference? Remember that the negative is not included in the what's this? It's not included in the expressing the base into root, into its exponent. So we have there negative 2 times 2. It's something like this. Or you can just have like 2 squared 2 times 2. You can have like that because here the exponent only tells you to multiply the base twice, not including the sign. But in here, it says negative 2 times negative 2. So this one is 4 positive and this one is negative 4. Remember this stuff, okay? Anyway, so we have here, yeah, try to check that. Okay, so in this case, we have here, like x squared minus 1 squared. This is already in this case, so we have here x plus 1 times x minus 1. That's it. Okay, another variant, 25x squared minus 4. So we have there what? How are we going to do this one? We have here express each into exponential form of 2. So we have here 5 squared, x squared minus 2 squared. This one have the common exponent 2. So try to put it out. So we have there 5x in the parenthesis squared minus 2 squared. So this is just the same as like multiplying 2 with the exponent of 5, which is 1 and 1. So we have 5 squared and x squared still. Now this is already in this case, in this form, I'm sorry, this one. So we have here 5x minus 2 and 5x plus 2. That's it. That's how you're going to factor it. Okay, another variant. So shall I say we have 50, say 8x4 minus 2y squared. Okay, now this is still in this variant, so we have in this case, so we can have like express this one. Now, in this case, 8 and 2 are not perfect square because this one is a perfect square, right? 25 and 4, 1 and 7 and 9 are perfect squares. What if like there's like this? In this case, if you'll see differences of squares or like the exponents are multiples of 2, 2, 4, 6, 8 and stuff like that, and the sign in between these two are is minus, and there are only two terms. Okay, terms is the terms that is being referred to here is like the how many times you can see this one, because after the plus and the minus, just like that. So this on first term and second term. Now if there are two terms and the sign in between them is negative or minus and the exponents are in the multiples of 2, this is in this case. Okay, this is one of the tips. The strategy is, now this one, we cannot express this one because they're not perfect squares, but actually they're common. So you can take that common out. So we have common of 2 and common of 2. So put that 2 out, and then 8 divided by 2. So we have 4, and then x4, and then minus 2 divided by 2. That's 1. So we have just 1 squared, y squared. Okay. Now this is perfect, and this is also perfect. Perfect square. So we can have like 2 times 2 squared, and then x squared squared. Because x4 is x squared times squared. Multiply that, that's just x4. Minus y squared. And so in this case, so we have put the square common out. So we have 2 times 2x squared squared. We just put this 2 square out, so we have 2x squared. Okay? 2x squared, and then minus, minus y squared. Now, we have arrived in this form. So we can just factor this one out. So we have there 2 times 2x squared minus y, and then 2x squared plus y. That's it. There you go. This is the factored form of this one. So short, but so long. But too long. Okay, anyway. That is, this is just like first rule of the special products and factoring. Difference of two squares. This is the name of this, difference of two squares. And I have shown you like the variants in different examples using those variants. Okay. Next rule, we have here this case. We have second rule, a plus b squared. Okay, so this one is a squared plus 2ab plus b squared, or you can have like a minus Okay, second rule. As you can see this one, we have the plus and the minus. Uh, why like this? Just if you say this kind of expression or this expression, you can just do the opposite. Anyway, like why like this? Let's try to do the FOIL. A plus B squared. This is equal to A plus B times A plus B. FOIL method. So we can do like that, like this, and like that. Multiply A times A. So we have here A squared. A times B, that is plus AB. B times A, that is also plus AB. And then B times B, that is plus B squared. Now, there's one are just the same. So we can say A squared plus AB plus AB. We have 1 plus 1, so we have 2AB plus B squared, which is just the same as that. So there's no need for you to solve like this one if you have mastered this rule. Okay? There's two rules about. The same as this one, if you're going to change this one into minus, so we have like this, we have like that, we have like that. And this one will change, and this one will change, and this one will change, which is also the same as that one if you're going to change it, right? So, if you see this kind of word problems or word problems pertaining to this or using this one, you can just use the two.